In this video, we'll be continuing Chapter 4. This is Chapter 4, Section 7, Proportional Relationships. What you'll learn in this section is to identify proportional relationships and find constants of proportionality. Remember, ratios form a proportion when they are equivalent. The only term you need to define in this video is the constant of proportionality. Let's look at Keisha. Keisha is a cyclist. We know the total distance she traveled at different times during a bike-a-thon. You can display the times and distances in a table or a graph such as you see here. Then you can determine if the times and distances have a proportional relationship. If they do, you can use the data to find the average speed at which Keisha rode. So if we look at these, we're going to look at it as distance over time, because when you're trying to find a rate of speed, your equation is rate equals distance over time. So when we look at our proportions, we're going to look at them as distance over time. So we're not going to bother with 0 over 0 because that's just 0. So then our distance, our first distance is 13 miles in 2 hours. Then we want to see if these are equivalent, so we're going to be putting equals lines between our different ratios, forming our proportions. Then we have 26 miles over 4, 32 miles over 5, and 45.5 miles over 7. Now we can look at these and see if they form a proportion. Now we know 13 times 2 and 2 times 2 get us to 26 and 4. Gets a little trickier farther down because it's not a simple multiply by 2. So we have to look at, okay, we need to get a unit rate. We know to get a unit rate we have to get something down to 1. So to divide by 1, to get the down to 1, we have 13 over 2. We're going to divide both the top and the bottom by 2 to get the bottom number to be a 1, which gives us 6.5 over 1. So each one, or each mile is going to be, each hour is going to be equal to 6.5 miles. So if we want to see if 5 works, we're going to take 6.5 times 5. So 5, 32, 32.5. So this is in proportion because it follows our unit rate that we just figured out. We're going to do the same thing for 45.5. We're going to see if we take our unit rate of 6.5 and multiply it by 7, do we get 45.5? And 5.7 is 35, carry the 3. 6 times 7, 32, plus 3, 42 plus 3, 45. Put in your decimal point, so yes, that one works too. So because all of these are in proportion and they follow our unit rate that we figured out, this is in a proportion. So the ratios are equivalent. So there is a proportional relationship between the time and the distance. Pause the video and do these two in your notebook. Notice it says explain. You don't get to just say yes or no. You have to explain why there is or is not a proportional relationship. The graph of a proportional relationship is a straight line through the origin 0, 0, which is the point 1r on the graph of any proportional relationship represents the unit rate. So the line's going to start at 0, 0 and go up through the points of the proportion, or through the points of the proportional relationship. Now let's look at using a graph to find a unit rate. The graph you see here displays the data given in our table that we used in the previous example that you also see here again. Keisha's speed is the unit rate. We were going to use the graph to find the value of r in the ordered pair 1r. The line passes through 0, 0 and 213. So it must also pass through 1 and 6.5 since r equals 6.5. The unit rate is 6.5 miles per hour. Keisha's speed is 6.5 miles per hour. The way you can figure that out using a proportion is you'll have R over 1 equals, and then just pick one of your points. So if we use the 2 and the 13, it would be 13 over 2. Then you can use your cross products and solve, which gets us to 2R equals 13. Divide both sides by 2, and that gets us again to our 6.5. So we solved for R, so R equals 6.5. Pause the video and try these two in your notebook. The value of the ratio of quantities in a proportional relationship is called the constant of proportionality. This value is also equivalent to the unit rate. Now let's look at using a ratio to identify a unit rate. This table shows a proportional relationship between the number of minutes and the amount the customer pays for cell phone service. Let's try to identify the constant of proportionality. So first we need to set up a ratio. So we're going to have the price over the minutes used. So we can pull any set of data. So we'll start with the first one. So the first dollar amount we have is 10, and the first minutes used is 100. So you're simply going to simplify that ratio. So 10 over 100, a ratio is something you find by dividing, so we're going to divide 10 by 100. So 100 can't go into a 10, obviously, so we add a decimal and add a 0. Now 100 goes into 100 one time, so our unit rate is 0.1. It's just that easy. Just divide the top number by the bottom number. So we can go back and check this to be sure that our unit rate makes sense. So if we have our unit rate is 0.1, so that would be like having 500 times 0.1 equals 50. So we have for $50, they got 500 minutes, so that works. How about if we do the big one? We'll do 1,500 times 0.1. That gets us 150. 1,500, 150. That works. Let's do the last one. 1,000 times 0.1 equals 100. 1,000, 100. That works. Now that we know the unit rate, we can write an equation that represents the proportional relationship. So that's like we're going to write our proportion for the cost per minute. So we use the constant of proportionality to write an equation to find the price P per minute M. So the price equals our unit rate of 0.1 times M. So now any amount we plug into our constant of proportionality or into our equation, it will always come out with the right answer or the right amount that we're looking for. Pause the video and do these two in your notebook. Pause the video and do the check your understanding in your notebook. Be sure to write down the original questions and show all your work. Enjoy the rest of your evening, and I'll see you tomorrow.